Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonkar. Let's continue with our discussion of NCERT Science series. You already know that we are into NCERT Science textbook for class 10, where we are proceeding with discussion of each chapter. I hope that you've seen our previous video lectures where we discussed chapter 1, chemical reactions and equations, chapter 2, acid, bases and salts, and chapter 3, metals and non-metals. Today, we will be moving ahead and discussing all important chapter 4, that is carbon and its compounds. Now, before we move ahead, there have been some inputs, some messages from aspirants I received on Instagram. People have requested to have classes daily. See, there have been some delays, some gaps with NCERT discussion. It is because of two reasons. First one, because of some other engagement. Second one is because of the lengthy nature of the content. You must have seen that the chapters and then content is becoming more and more complex. Our videos, our video lectures are also getting more lengthier. So there have been some gaps. So apologies for that, but be sure that we will be completing this series slowly and steadily. All right. Let's move into chapter 4, carbon and its compounds. Now here we are going to discuss about carbon. Carbon is omnipresent. Carbon is present in different forms. A child writing with a pencil has graphite in it. It is made up of carbon, or it is composed of carbon. A woman wearing a diamond, the diamond is nothing but pressurized carbon. Living organisms have carbon or its compounds. In fact, our body is largely made up of carbon, hydrogen, oxygen, nitrogen based compounds, if not free in form of compounds. That means carbon is a part of abiotic as well as biotic ecosystem. So we'll talk about different characteristics of carbon, why carbon is so versatile, why it has so many compounds. All right, that's the agenda of today's discussion. Let us begin. But before that, you do know that StudyIQ is offering Prelims to Interview initiative. Our batch is beginning from 22nd of July. We are offering this program in 3 formats: English, Hindi, and in a bilingual format. Classes are scheduled at 6 p.m. This is the most comprehensive program for your UPSC civil services preparation. If you have not enrolled, do it now. If you know anybody who's looking for preparation for UPSC civil service examination to become IAS, IPS, do let them know about this program. Use the code Rahul Live whenever you check out. You will get maximum discount on the website as well as the app. Do it now. I'll see you in the class. All right, let's talk about carbon and its compounds. As I told you, carbon is omnipresent. Carbon is everywhere. Now, if you look at this particular shirt, the shirt is made up of cotton. Cotton has cellulose. Cellulose is made up of glucose. Glucose has carbon in it. If you look at your food, what are carbohydrates? Carbohydrates have carbon. Proteins also have carbon. Proteins are nothing but amino acids. Amino acids have carbon. Fats, fatty acids, they also have carbon. That means carbon is almost everywhere. And it is very strange when we look at the composition of carbon in Earth, be it Earth crust or in atmosphere, it is very minuscule. In Earth crust, only 0.02% of carbon is present. And in our atmosphere, we have already seen it is about 0.03 to 0.04 percentage in form of carbon dioxide mostly. But despite such low proportions, carbon is available everywhere in nature. As I told you, it is everywhere. It is in our body, it is in equipments everywhere, it is in all the things that you see. It's in the gas that we exhale out. So carbon is everywhere. Carbon is very versatile. It can react with many other substances. It can react with oxygen, it can react with nitrogen, it can react with carbonates, it can react with other stuff to prepare or to end up with different compounds. So let's talk about carbon. All right, what are the characteristics of this carbon? First of all, carbon, we represent it like this. That means carbon has atomic number of 6. It has atomic mass of 12. We have already discussed the isotopes. I've told you that carbon is present in 2 different isotopes. One is 6C12, that means carbon 12. We also have carbon 13 and we also have carbon 14. We know about this, right? Carbon 14 is used in radiocarbon dating. Carbon, in fact, is 4th most abundant element present in the universe itself. All right, after hydrogen, helium, and oxygen in the universe. I'm talking about not just Earth, in the universe itself. Apart from that, carbon is present in form of different allotropes. Carbon is present in free form as graphite, in pressurized form as diamond. Carbon generally is very inert. Carbon is generally inert in normal conditions, but it forms different compounds. Carbon is non-metallic. Carbon is tetravalent, and tetravalency is one of the most important properties of carbon. We'll talk about that in some time. Tetravalency means carbon generates 4 electrons and carbon forms covalent bonds. Carbon comes in different shapes, and carbon is a chemical element. It forms bonds with different elements like oxygen, nitrogen. It forms bonds with metallic as well as non-metallic elements. That is why carbon is omnipresent everywhere. In fact, when we talk about carbon, carbon is present in crystalline form. It is present in crystalline form as diamond. As I told you, if you have diamond, if you have a diamond ring or if you have a diamond necklace, the diamond is nothing but pressurized carbon. Carbon is present in graphite form. Carbon is also present in fullerene form. We'll talk about this in some time. Carbon is also present in amorphous form. Amorphous means powdery form. Basically, it is present in charcoal, amorphous, non-crystalline, non-solid form, coke, lamp black, or gas carbon. So carbon is very widely distributed almost everywhere. Carbon, as I told you, it is a part of living system. Carbon is present in living organisms. Our body has carbon in large amount. Plants use carbon dioxide for photosynthesis. Carbon is present even in non-living things. That means carbon is everywhere. Carbon is essential for photosynthesis. It is there in plant tissues, it is there in animal tissues, it is there as fossil fuels, as gas, as petroleum, everywhere. Carbon can occur in free state or in combined state as well. And I told you that carbon is present in different allotropic forms, meaning carbon in its free state can become diamond if certain conditions are met. Carbon in a pressurized form, it can become diamond, and diamond has very different characteristics. Diamond has shiny appearance. Diamonds are very, very costly. Carbon is also present in this particular format as graphite. As I told you, a child writing with pencil, that pencil has graphite. Carbon in its I would say nanostructure, it has different structure itself, like C60, that is fullerene. These days we talk about nanotechnology. We lead, or we create nanomaterials or nanoparticles. Carbon based nanomaterials include graphene. Graphene has novel properties. Graphene has in fact revolutionized the field of nanoelectronics. Now, what is this graphene? Now, this graphene is one carbon atom thick structure which shows novel properties. Similarly, we can make carbon nanotubes. We can make carbon fullerenes. These fullerenes are again nanomaterials which are in this round ball-like structure. It is also called buckyball. And these fullerenes have found application in many sectors. Say, for example, for gas storage, for drug delivery purposes, so many R&D stuff is going on nanomaterials, carbon-based nanomaterials. So carbon is present in different allotropic forms as diamond, as graphite, as fullerene, many other examples that I gave. What are some other characteristics of carbon? Let's talk about characteristics of carbon. Now, one of the novel characteristics of carbon is that it is tetravalent. We'll talk about this tetravalent. We'll be harping about this tetravalent continuously in this interaction. Now, what is the meaning of tetravalency? See, carbon in its normal form, I'm not talking about different isotopes, I'm talking about normal carbon form, we represent it as carbon 12. That means it has atomic number of 6, it has atomic mass of 12, meaning it has 6 protons, it has 6 neutrons, and protons or neutrons, where do we find them? We find them in the nucleus. All right, and it has 6 electrons. It has 6 electrons. Now, you do know that in the K shell, only 2 electrons, they fulfill K shell. So, 2 electrons in the first shell, and in the outermost shell, you have 4 electrons. You have 4 electrons. And we have already discussed that every element, it tries to achieve that stable configuration of the noble gases. That means it tries to achieve that octet, the stable octet. Now, to achieve that stable octet, carbon has 2 options. Since it has 4 electrons, what carbon can do? is it can give away its 4 electrons, or it can accept 4 electrons from some other element to reach that stable level, stable configuration. And this is where the catch comes. This is where the versatility of carbon comes in. Because of its tetravalency, what happens? Carbon, since it has 4 electrons in the outermost shell, what it does is it does not lose out electrons, or it does not gain electrons, but it shares electrons. A very interesting characteristic of carbon. And when you share these electrons, it leads to formation of covalent bonding. And another very important idea is that carbon can share its electrons with itself. I told you that carbon is present in different allotropic forms, meaning one carbon atom, if see, how do we represent it? We represent this covalent bonding in dot structure. This carbon atom is going to share one electron with another carbon atom. It is going to share another electron with another carbon atom. It is going to share third electron with another carbon atom, and the fourth electron with another carbon atom. And that's why we find carbon in different configurations, in different structures. The structure of diamond is something like this. The structure of graphite is cylindrical in shape. The structure of buckyball or fullerene is round in shape. But in each and every case, one carbon atom is sharing its electrons with another carbon atom, something like this. Or we can also represent the dot diagram as something like this, where the carbon is sharing electrons. So it shares a pair of electrons or multiple pairs of electrons, not just with itself, but it can also react with other elements. Now, this is a slide from a previous discussion. Now, we saw that element, its atomic number and number of electrons in its outermost shell. Now, I told you that noble gases, they are most stable. If you look at this, they are most stable. They seldom react. Now, the question is with other metals and other non-metals. Now, when you look at carbon has a valency of 4. Its valency is 4. It has 4 electrons which it can give away or accept, but it does not do that. It shares electrons with others. For instance, chlorine, it can share 1 electron with chlorine. It can share 2 electrons with sulfur. It can share 3 electrons with phosphorus. Or if you look at nitrogen and oxygen here, now to complete octet of nitrogen, to complete octet of oxygen, what happens? This nitrogen, it can accept 3 electrons, oxygen can accept 2 electrons. So nitrogen can share 3 electrons, oxygen can share 2 electrons with carbon to form respective compounds. In fact, please remember, it's not just carbon that forms these covalent bonds. In fact, other elements like hydrogen, they also share electrons. Elements like oxygen. Now, oxygen, you do know oxygen molecule is O2. Now, what is this O2? In this O2, one oxygen molecule, it combines with another oxygen molecule, or it shares electrons with another oxygen molecule to form oxygen atom, to form oxygen molecule, that is oxygen gas. Similarly, oxygen has a double bond. For nitrogen, they share 3 electrons. That's why they form nitrogen gas, N2. It's not just carbon, but others also do this. And that's why carbon reacts with these also, forming a covalent bond. Now, what is this covalent bond? Please remember, we have discussed in our previous interaction, ionic bond between sodium and chlorine, Na plus and Cl minus. Right? These two ions form to an ionic bond. But in case of carbon, a covalent bond is formed. Covalent bond is formed when atom of one particular element and atom of another element, they share electrons. When a bonding is formed by sharing of electrons, sharing of one pair or multiple pairs of electrons, covalent bond is formed. Now, what kind of covalent bonds we observe? We can have a covalent bond which is single bond. That means sharing of one electron from either side. It can also be a double bond, which we classically find in carbon dioxide. Why? Because carbon, it forms a double bond with oxygen. All right, because you do know the valency of carbon is 4. So it forms a double bond with oxygen. Similarly, it can also lead to formation of triple bonds. We find triple bonds in many of the unsaturated hydrocarbons. All right. So covalent bond, very important. Now we discussed ionic bond before as well. As I told you, ionic bond is formed between two atoms. When atom 1 and atom 2, they transfer electrons to each other, then ionic bond is formed. Ionic bond is because of transfer of electrons, whereas covalent bond is because of sharing of these electrons. Please remember this. All right. Apart from that, there are some other characters which have been discussed here. Ionic bond is normally found between metal and a metal, or a metal and non-metal, but covalent bond is generally found between non-metals. And a covalent bond is because of sharing of electrons, not transfer of electrons. Shared electrons leads to covalent bonds. Transfer of electrons leads to ionic bonds. We have already discussed that the ionic compounds like sodium chloride, they have very high melting point and very high boiling point. But covalent bonded compounds, they have low boiling point and low melting point. Apart from that, we have already discussed ionic compounds are generally crystalline, they are hard and brittle, and they have strong bonds. But the covalent compounds with covalent bonds, they are liquids or gases at room temperature. They are relatively softer, even if a solid substance is formed, that is organic compound. Apart from that, their bonds are normally weaker than ionic bond. Please remember, when I write weak bonds for covalent compounds in comparison with the ionic bond or the metallic bond. In fact, this is the hierarchy of the strength of different bonds that we have. A metallic bond is extremely strong. Then you have ionic bonds at the second number. Now, a little weaker than ionic bonds are the covalent bonds. Then the hydrogen bond, dipole-dipole bond, and London dispersion forces. So we'll talk about these bonds also in our subsequent classes. But do remember this sequence, because sometimes a simple question can be created that metallic bond is stronger than ionic bond is stronger than metallic bond, or with respect to covalent and ionic bonds. Please catch those things. Do not fall in the pit and commit a mistake. Right? When I say do not fall in the pit, it's metaphorical. All right. Let's move on. This is the bond strength, difference between covalent bond and ionic bond. Let's move ahead and talk about carbon and its characteristics. Why carbon is so versatile? Now, by now, you have already understood that tetravalency is one of the important characteristics of carbon, which leads to its versatility. Tetravalency means it has 4 electrons which it can lose or it can gain, but it does not do it. It shares it with different elements, different atoms, to create different compounds. So it reacts. It is capable of forming covalent bonds. It's capable of reacting with others like oxygen, hydrogen, nitrogen, sulfur, chlorine, leading to different compounds with different properties. Apart from that, the bonds that the carbon forms with others, they are fairly strong. When I say strong, again, I wrote weak in comparison to ionic bonds, but they are fairly strong in comparison to other bonds that are present. It is stronger than the hydrogen bond itself, right? Now, apart from that, there is one more reason for these strong covalent bonds with carbon, and that is size of carbon itself. Please remember this particular pointer, that covalent bonds of carbon are strong because carbon is of smaller size. Now, this is a very important property that you need to remember from MCQ perspective. The larger the atom size, larger the atomic size, weaker would be its covalent bonds. Please remember, and smaller the atomic size, stronger would be the covalent bond. Now, it makes sense also. If the atomic size is smaller, that means at the nucleus where there is positive charge, it is going to hold the shared electrons together, making the covalent bond more strong. It's a very important pointer from exam perspective. Now, apart from tetravalency, there is one more important property of carbon. It is called as catenation. Now, catenation is a self-linking property. As I told you that carbon can share its electrons with itself, or it can share its electron with other elements, other atoms as well. When it forms a bond with itself, it is called as catenation. And catenation is a property because of which carbon can form bonds and leads to formation of larger molecules, and these larger molecules, they give rise to different kind of compounds. Now we call hydrocarbons. Now it has the property to first of all form a bond with itself and bond with hydrogen. That is why in our organic chemistry we have so many compounds which are carbon dioxide and hydrogen itself. We call them hydrocarbons. Why do we get them? Because of the property of catenation. That means we can add hydrogen to it, we can add more carbon to it, we can add other compounds as well. We'll talk about these hydrocarbons in some time. So carbon is versatile because of two reasons. First one is because of tetravalence, and the second one is because of the property of catenation, where it can lead to formation of different kind of branched molecules. For instance, carbon can lead to a straight chain carbon compound. Carbon can lead to a branch chain carbon structure. It can also lead to different branch chain carbons, something like this, or it can also lead to cyclic carbon compounds. We'll talk about them in some time, but I hope that you have already gained the insight that carbon is very versatile because of two reasons: tetravalence and the property of catenation, right? So you need to remember, if I ask a question MCQ that what is catenation, what is catenation? Catenation is a self-linking property of an atom where it can link with itself through different bonds. It can link with itself or it can link with others as well. So if it links with itself, it forms a branch structure. Carbon has the ability to do it. Now apart from carbon, there is one more compound you can see here. Now in addition to carbon, atoms may be atoms of different, say specifically silicon. It can also lead to some sort of catenation, but silicon based compounds are rather unstable. Carbon compounds are much more stable. Silicon also has this property of catenation, right? Now let's talk about organic and inorganic compounds, because due to this property of catenation of carbon, we find many carbon and hydrogen based compounds, and these carbon based compounds which occur mostly in nature, they are called organic compounds. Now organic compounds are those that contain carbon usually bonded with hydrogen. For example, there is methane, ethane, ethanol, propanol, all these organic chemicals. Inorganic compounds or inorganic chemistry basically deals with inorganic compounds that don't have carbon. But please remember, when we talk about organic and inorganic compounds in general are compounds that contain carbon and that occur naturally. Apart from that, inorganic compounds, it includes carbides, oxides of carbon, carbonate, and hydrogen carbonate. Please remember, carbon compounds except for carbides, oxides of carbon, carbonates, hydrogen carbonates, they continue to be studied under organic chemistry. Apart from these, apart from carbon dioxide, carbonates, and other cyanides, carbides, they form part of inorganic chemistry. So organic chemistry means compounds that are composed of carbon in general. That's the general formula or general understanding. All right. Now let's talk about these hydrocarbons itself. That means we are entering the domain of organic chemistry. What are hydrocarbons? Hydrocarbons are a class of organic chemical compounds that are composed only of carbon and hydrogen. Carbon atom joins together to form a framework. As I told you, carbon can undergo catenation. Carbon can also form bonds with hydrogen. All right. So compounds in this particular form, in this framework, classic example, right? So hydrocarbons are the primary constituents of your petroleum, your gas. The LPG that comes at your home, that is nothing but hydrocarbon itself. Now LPG is predominantly composed of propane and butane, right? Largely propane and butane. Those are nothing but hydrocarbons. Hydrocarbons are also part of living system. Hydrocarbons, they occur in nature, they are present in plant itself. They form different pigments. For example, carotene is that orange. You find that in a carrot, the orange or the reddish color is because of these hydrocarbons itself. Apart from that, hydrocarbons are present almost everywhere. As I told you, this cloth, cellulose is nothing but hydrocarbon itself, an example of hydrogen, carbon, and oxygen element. But when you talk about, say, rubber, right, naturally occurring rubber, that is nothing but hydrocarbon itself, right? So it is present almost everywhere. Hydrocarbons are also present almost everywhere. So the next question is, sir, how do we classify these hydrocarbons? Hydrocarbons are classified in two categories. One is saturated hydrocarbon. Now, saturated hydrocarbon is one in which that compound will have only single bond between carbon, only single bond. So, saturated hydrocarbon means which have single bonds. You can note here saturated hydrocarbons, example is alkane. But once any carbon or any pair of carbon, they have double bond or they have triple bond, then they become unsaturated hydrocarbons. Now, saturated hydrocarbons, unsaturated hydrocarbons, that is from the perspective of carbon atom or carbon element, where in this sense means if there are just single bonds, then one atom of carbon, it has been saturated to 4 different bonds. But here there is only in these cases there is double bond or triple bond formation, because the other conjugate element or conjugate atom, it is in deficient quantity. That's the basic understanding. Meaning unsaturated hydrocarbons are the ones which have double bond, triple bond. Just remember this particular factoid. All right. Now the next thing, how do we name these hydrocarbons? Because hydrocarbons are a class of compounds and in different framework because of the catenation property of carbon. How do we go for nomenclature of hydrocarbons? The first thing that we see is the number of carbon atoms. Now, if number of carbon atoms is 1, we use a prefix called as meth. If the number of carbon atoms are 2, then eth, 3 prop, 4 butane, but right, 5 pent, hex, hept, oct, non, dec, right? Then what is the corresponding conjugate of this carbon? We try to see that. We try to see what is the conjugate or what is the different functional group to it. If it is just hydrogen, if it is saturated, then there is a nomenclature procedure. If it is saturated, if all hydrogen bonds have saturated the carbon, then we call them in short as alkanes. That means I call it methane, I call ethane, I call propane, butane. And if they are unsaturated, then we call them alkenes and alkynes. Apart from that, if the functional group is different, for example, if the functional group is the alcohol group, then I use all in front of it, methanol, ethanol, right? I use that depending on the functional groups. All right. So based on this nomenclature of hydrocarbons, I create different homologous series. Now, homologous series of hydrocarbons is a series or a collection of organic compounds which are identical in structure and identical in chemical characteristic, but they only differ in a CH2 group which is missing. Now, if you have not understood what is the meaning of homologous series, then let's look at an example. Now, a homologous series of alkanes is this. Nomenclature we have understood. There is only one carbon atom, that means meth. Then homologous series, where you see that all the carbon atoms here, they have saturated. That means for one carbon there are basically four hydrogen atoms here. That means saturated hydrocarbon, and we give name it as methane. So if we look at this homologous series, there is methane, ethane, propane, butane, pentane, hexane, heptane, right, octane. You go in that particular series, this becomes the homologous series of alkanes. Now, if you look at the difference between methane and ethane, you will see that the difference is only CH2. That's the basic idea. Similarly, alkenes are hydrocarbons which are unsaturated. Now, you will see here ethene, propene, butene. Look at this suffix. The prefix would be very similar, right? The first one would be methene, right? All right. Then you have got alkynes. Now it should be alkynes. Something missing here. The same stuff has come here. Do not refer to this particular part. But when you look at alkynes, you will get ethyne, propyne, butane. They're called as alkynes because of the nomenclature we saw the suffix. Apart from that, depending on the functional grouping that we have, we give the name to hydrocarbons as if there is a conjugate or if there is a functional group chlorine or bromine, that is called as halo haloalkane, haloalkene. If there is alcohol group, that means OH group, we name it as all. We give an all suffix to it. Let me give you an example. If it is a haloalkane, meaning there is a combination of carbon and halogen, that is chloride. So we have examples of CCl3, that is carbon tetrachloride, CCl4, carbon tetrachloride is there. Chloroform, that chloroform is a compound which is haloalkane, CHCl3. This is chloroform. You have different alcohols. Whenever there is OH group like this, the functional group, then we suffix it with all. That means propanol, butanol, ethanol, methanol. If there is aldehyde is CO, we give it propanol, methyldehyde, acetaldehyde, formaldehyde. If you have a ketone group, you give it ONE. Here it is propanon, butanon. Carboxylic acid, if it has carboxylic acid group, then we give it oic acid. We name it as oic acid. Methanoic acid, ethanoic acid, propanoic acid. We'll talk about these later on also. So you have alkenes and you have alkynes here. Now it should have been here, it should have been alkynes, right? Alkynes, both have been alkenes here. That's a small mistake. But if they are alkynes, we give it a suffix YNE, propyne, butane, methine, right? So that's the nomenclature. Apart from that, hydrocarbons in cyclic structure, they are of two categories. Hydrocarbons which are in cyclic framework, cyclic hydrocarbons, alicyclic hydrocarbon and aromatic hydrocarbons. Now alicyclic are the ones which are basically the alkanes which are in cyclic format, cyclopropane, cyclobutane, cyclopentane, whereas aromatic hydrocarbons are the cyclic compounds of carbon and hydrogen, like benzene, naphthalene, benzaldehyde, acetaldehyde, etc. Right? Sorry, not acetaldehyde, benzaldehyde. All right. So this is the example of cyclic hydrocarbons. Now, the next thing that we are going to discuss is the chemical properties of these hydrocarbons. The first property, combustion. Now, as I told you, hydrocarbons, they form majority of fossil fuels, or your what you extract from your fossil fuels. The gas that you extract, it has hydrocarbons. In petroleum, you have hydrocarbons. That means they burn. So how do they burn? They mix with oxygen to give you carbon dioxide, to give you water, and to give you heat and light. So they undergo combustion. Reaction. They combine with oxygen to give you these compounds. In fact, when you look at hydrocarbons, you will see that the saturated hydrocarbons, they always burn with a clean flame. That is why in your LPG you have butane and propane. When you burn LPG, it gives you clean blue flame. But if a hydrocarbon is unsaturated, then it burns with yellow flame, giving you a lot of black smoke. But in general, be it saturated or unsaturated, if you do not provide it enough oxygen or enough air, then there would be incomplete combustion. That means some amount of soot or black substances would be released for sure. That is why you must have seen whenever your gas nozzle or your whenever there is air which is in deficient amount, you will see that on your cooking utensils at the bottom, you will see some deposit of black soot or some black deposition at the bottom. But in general, remember, saturated hydrocarbons, they burn with a clean flame. Unsaturated hydrocarbons, they burn with a yellow flame, giving a lot of gases. We have fuels such as coal and petroleum. They not just contain carbon and hydrogen, but they also contain different impurities. They also contain nitrogen, sulfur. So when they are burned, you get a lot of pollutants like oxides of nitrogen and oxides of sulfur. That leads to pollution. All right. Now, apart from this, when you look at oxidation of these hydrocarbons, this is basically ethanol. Now, ethanol can be oxidized by strong oxidizing agents like alkaline potassium permanganate or potassium dichromate, acidified potassium dichromate. Now, in such scenario, the ethanol can basically lead to acetic acid. It leads to formation of acetic acid. So Alcohol is transformed into an acid through oxidation by strong compounds or strong reagents. Apart from that, addition reaction. This is very important. Addition reaction. Now, addition means addition to add hydrogen in presence of some catalyst to a hydrocarbon. When I add hydrogen to it, it is called as hydrogenation. How can I add hydrogen to a hydrocarbon compound? It is through some sort of a catalyst. Catalyst is something that enhances the rate of the reaction, that aids in the reaction. Now, for hydrogenation reaction, we use catalysts like nickel or palladium. And we have seen these experiments in our day-to-day life as well. Now, hydrogenation of vegetable oil is very prominent in our everyday life. Vegetable oils are generally liquid form, right? Liquid form. But once we process vegetable oil through hydrogenation reaction, then it leads to solidification of that oil. So transportation becomes very, very easy. So vegetable oil, when it is proceeded through this hydrogenation reaction by using nickel catalyst, it leads to saturated hydrocarbons. Please remember, vegetable oils that we consume, they have unsaturated fatty acids. But once we push them through the hydrogenation reaction, it leads to saturated fatty acid. Now you must be thinking, sir, in case of fuels, if it was a saturated fuel, it gave clean flame. If it was unsaturated fuel, then it gave yellow flame. But when it comes to fats, do remember the pointer that for our body, when I talk about fatty acids, when I talk about lipids, I would like to have unsaturated fatty acids because they are good for our health. Unsaturated fatty acids are found in vegetable oil. We have the mustard oil, we have sunflower oil, safflower oil, groundnut oil. Those have unsaturated fatty acids which are good for our health because the fat deposition does not occur in our blood vessels, in our arteries. Why? Because liver is able to take the fat, because these unsaturated fatty acids, they contain high density lipoprotein, and this high density lipoprotein, it can also help in elimination of the other low density lipoprotein that we consume, because liver helps in detoxification of that. But once our body starts to accumulate these saturated fatty acids, they would be stuck in our body. Cleaning them becomes very tough. Then it leads to different diseases. That's why hydrogenated oils, it should not be consumed. Remember that our vegetable oils that we have, they are unsaturated fatty acids, and when we run them through the hydrogenation reaction by using nickel catalyst, it leads to creation of saturated fatty acids, and many saturated fatty acids, they are trans fat. Now you must be thinking, sir, if this is the case, then why do people do it? See, because the trans fat or the hydrogenated oil, it is easy to transport. It has longer shelf life because it solidifies at room temperature. When you heat it, it becomes liquid. It solidifies at room temperature. Meaning, when you fry food in it at room temperature, there would be a layer of oil which would be on that food. So the food and its shelf life is also enhanced. Apart from that, it also acts as taste enhancer. That's why people consume a lot of hydrogenated oil. That food, it tastes good, right? The normal samosas that you have, the chola bhatures that you have, the fried food that you have, it will have a lot of saturated fat, especially the street foods that we have. And do remember that WHO has a limit that you need to have trans fat, which is approximately 5 gram per day. If it breaches 5 gram per day, then that fat, it would not be removed from your body very easily, and it would be deposited in your body. It would be deposited in your blood vessels. It would be deposited in your arteries, and if it enters into your coronary artery, it starts depositing there. It leads to disease, finally heart failure, heart stroke as well. So please remember that trans fat is one of the main ingredients in the food processing industry. Although these days you will find that there have been many rules and regulations, and a lot of food products that you buy, you must have seen zero trans fat or trans fat free. In fact, Vanaspati, or the colloquially we call it Dalda. It's actually a brand name, but Vanaspati is the product. Dalda have recently, a few years back, they announced that they are also trans fat free. But do remember, from health perspective, unsaturated fatty acids are good for our health. Saturated fatty acids are not very good for us. There is a limit to the amount of saturated fatty acids that we must consume. All right. Now, apart from this, the hydrocarbons, they can also undergo substitution reaction. Generally, hydrocarbons are fairly stable, fairly unreactive, but when we add chlorine to it, chlorine, the halogens, then substitution happens, and we get carbon, hydrogen, and chlorine based compounds, right? We have a carbon chlorine compound, as I told you, CCl4, which is used in cleaning industry. Carbon tetrachloride is used in cleaning industries. We have CCl3, which is nothing but chloroform. You must have seen in movies. Put chloroform on a handkerchief and person will become unconscious. So these compounds are created through substitution reaction. All right. So these are some of the characteristics of carbon, hydrocarbons. And now let's talk about some of the commonly used compounds in our day-to-day life. Let's talk about their characteristics, because it's very important. In our day-to-day life, we have so many hydrocarbons that we use. One of them is ethanol. You must have heard about ethanol. Ethanol is the second member in the homologous series of alcohol. Please remember, homologous series simply does not mean alkane, alkenes, and alkynes. Homologous series can also be of alcohol, meaning methanol, ethanol, propanol, butanol, pentanol. That is also homologous series. Or for example, say acid, methanoic acid, ethanoic acid, right? Propanoic acid, butanoic acid, that also becomes a class of homologous series. So in the homologous series, the second product is ethanol. Ethanol is ethyl alcohol. Now, ethyl alcohol can be prepared by fermentation of molasses. You know that in a sugar industry or a sugar factory, you get molasses. By fermentation of that molasses by yeast, you ultimately get ethanol or ethyl alcohol. The molecular formula of ethanol is C2H5OH. All right, C2H5OH. Now, OH is this functional group that is represented. That's why ethanol. Now, when we talk about ethanol, ethanol has certain characteristics. First thing is, ethanol is also a covalent compound. Ethanol is less denser than water, a little less denser than water. Its density is about 0.8. It has very low boiling point. Ethanol's boiling point is around 78 degree itself. And ethanol generally has a little unpleasant smell, not depending on the person. Some people might like that smell, okay? But jokes apart, ethanol has unpleasant smell and it has burning flavor in terms of taste. If you drink ethanol, it has burning effect throughout your body till it reaches your stomach. Because stomach itself is acidic, right? Now, apart from that, ethanol is neutral in general. It is neutral in nature, meaning if you put litmus paper in it, it is not going to turn its color. It is neutral. Its pH is around 7 itself. Apart from that, ethanol is extremely flammable. Now we have seen that hydrocarbons, they burn. Ethanol burns. Ethanol, when combined with oxygen, it burns in presence of air. It gives you carbon dioxide, it gives you water, it gives you heat and light. The same reaction that we saw when hydrocarbons are burned. So it burns, it gives you carbon dioxide, water, light, and heat. Apart from that, it also undergoes oxidation. We saw the oxidation reaction. Hydrocarbons can be oxidized using strong oxidizing agents like potassium permanganate or acidified potassium dichromate. This leads to creation of acid. That means ethanol, ethyl alcohol, it gets transformed into ethanoic acid. Ethanoic acid is nothing but the acetic acid. In our common colloquial language, is called acetic acid as well. Apart from that, ethanol can also react with sodium. Alcohols react with sodium, leading to evolution of hydrogen gas. How to understand hydrogen gas? You simply burn it. It will burn with a pop sound, right? So it leads to formation of sodium ethoxide. So ethanol reacts with sodium. Ethanol also reacts with or ethanol also when we heat it in excess sulfuric acid, ethanol from a saturated compound, it leads to becoming unsaturated. So it gives ethene. So when we heat it in presence of a strong acid, then saturated product is transformed into unsaturated hydrocarbon, that is ethene. These are some of the common reactions of ethanol. Now, apart from this, ethanol in our day-to-day life, we see it often. You must have seen a drunk person who's completely drunk on alcohol. They do not have consciousness, or they do not know what exactly is happening, because ethanol is present in their body. They have consumed ethanol, not pure ethanol, of course. They have consumed ethanol in form of that alcohol. All right. So in our day-to-day life, when large quantities of ethanol are consumed, then it impacts your central nervous system. It depresses your central nervous system. It leads to mental confusion, right? People feel light. Yes, it leads to lowering of inhibitions. You feel drowsy. That's why people have a habit of consuming alcohol, because it relaxes the central nervous system. It leads to inhibition. It leads to lower inhibitions, and you sometimes, if you consume too much, you lose sense of judgment as well. And ethanol is the prime constituent of that alcohol industry. Ethanol, whatever people consume, be it beer, whiskey, whatever, ethanol is the prime constituent of it. Of course, pure ethanol should not be consumed. Remember this: pure ethanol, if it is consumed, then it will harm a person more and more. Similarly, there is another alcohol, that is methanol, right? Methanol. Now, methanol, that is the first in the homologous series. Methanol is actually poison. If a person by mistake consumes methanol in the body, it leads to creation of methanol in liver. And when liver creates this methanol very quickly, rapidly reacts with the different components of cells, and it coagulates the protoplasm. That means in your cell, the protoplasm, it coagulates and stops working. The cells start to die, and ultimately it affects a person and may lead even to death. You must have seen in news so many times the idea of local alcohol. Have you seen it? Right? In many cases, the local alcohol that is created, it has heavy quantities of methanol, and people consuming methanol, they die. Right? You must have seen deaths because of the fake alcohols or the local alcoholic drinks that people create. So alcohol has this effect. Apart from that, ethanol or ethyl alcohol is also produced largely in industries. Now, this industrial ethanol should not be diverted towards other purposes. That's why ethanol is mixed with methanol, or many a times, to identify it, there is some sort of dye or some sort of reagent which is added to it, right? And such alcohols are called denatured alcohol. When dyes are added, you get blue color so that it can be easily identified. This alcohol is called denatured alcohol. Denatured alcohol. In fact, this ethyl alcohol is used in many industries. You must have seen during COVID-19, a lot of sanitizer was used. Sanitizer has alcohol in it, ethyl alcohol. Now, apart from this, ethanol can also be used as fuel. As I told you, ethanol burns. It undergoes the combustion reaction. It burns with air to give you carbon dioxide, water, heat, and light. So alcohol can also be used as fuel. And that is why you must have seen the government is running a very important program, that is ethanol blending in your petrol. Right now, ethanol is being blended into petrol, and the government has suggested that they are going to blend up to 20% of ethanol in petrol. Slowly and steadily, we are reaching towards that target. Already 5% ethanol blending is already happening, and that's why ethanol is being produced more and more in our sugar industry. The sugar factories, the cooperative sugar factories that are running, those are producing ethyl alcohol, ethanol from the molasses, and they are supplying that to the oil companies. That means the fuel that you are using right now, or which we will be using in future, it will have 80% petrol plus 20% ethanol. And for this, there is no need to change the engine composition, or slowly and steadily, if we try to increase this amount, we need to move towards changes in engine as well. All right. So This is some idea that you need to know, because when you're preparing for UPSC civil service examination, you need to understand that ethanol blending in petrol, it has its own set of advantages and it has its own set of challenges. You can read about the case study of Brazilians, how Brazilians have introduced different flexi fuel engines in their country. You can always read about that, right? Now, apart from ethanol, there is also acetic acid or the ethanoic acid. I told you that you oxidize ethanol using a strong reagent like potassium dichromate, it leads to ethanoic acid. Ethanoic acid is nothing but acetic acid. Now, acetic acid is a part of carboxylic acid group. Now, carboxylic acid groups are those acids which are generally found in nature. Right? For example, the citric acid, the oxalic acid, the folic acid, very similar to acetic acid. Now, acetic acid, when you add to water, 5 to 8% solution of acetic acid in water, this is called vinegar. Have you used vinegar in kitchen? Of course, you must have used. Vinegar is a common compound in many of the kitchens. The melting point and the boiling point of, again, acetic acid are quite low. Melting point of pure ethanoic acid is about 290 Kelvin, and it often freezes during winter. All right. So as I told you, carboxylic acids are those acids which are found in nature, and we have already discussed those are weak acids. That means in an aqueous solution, they do not ionize completely. Strong acids like mineral acids or inorganic acids like hydrochloric acid, sulfuric acid, they ionize completely in aqueous solution. So these carboxylic acids are weak acids. Now, acetic acid, it undergoes different kinds of reactions. When acetic acid is subjected to esterification reaction, esterification means acetic acid mixed with ethanol, ethyl alcohol under acidic condition, it leads to creation of different esters. And these esters are used in production of soaps. These ester based compounds are used in perfumes. They give good fragrance. They are used in making perfumes, and on treating with sodium hydroxide, which is basically an alkali, they would all again be converted back to alcohol. They can again be converted to alcohol as well. But this is basically the esterification reaction of ethanoic acid. Apart from that, when it reacts with a base, when ethanoic acid reacts with a base, you do know acid and base is nothing but neutralization reaction. Neutralization means it leads to formation of salt and water. What salt is formed here? Sodium acetate. When you add sodium hydroxide to acetic acid, it leads to formation of a salt, sodium acetate and water. Sodium acetate is again a very important compound. It is used in many industrial applications. For example, sodium acetate is used in textiles. It is used as disinfectant also in many cases. Similarly, when acid reacts with carbonates and hydrogen carbonates, it again leads to formation of salt plus water releasing carbon dioxide. We have learnt this when we discussed about acids. I hope you remember that. Do you remember? When acid, that means ethanoic acid, when it reacts with carbonate or hydrogen carbonate, it leads to formation of different salts. Same again, sodium acetate is formed. I told you applications of that. All right. Now, apart from ethanol, ethanoic acid, we regularly use soaps and detergents, right? We regularly use soaps and detergents. No? Have you taken bath today? You must have used some sort of soap, probably Lux, right? You must have used Lux soap, very, very prominent example. Or these days, say a costly soap like the Dove soap, right? Dove soap or Synthol, whatever soap you use. Soaps and detergents, they are produced by saponification reaction. Saponification reaction happens between sodium hydroxide, basically some base, sodium hydroxide or potassium hydroxide, and vegetable or animal oil. That means some ester. So when I add ester and a base, it leads to creation of alcohol and soaps. Please remember this. That's why we discussed this esterification reaction. From ethanoic acid, we got esters by reacting that with base. Now, when ester further reacts with base, it leads to formation of soap. Now, this is saponification reaction. So, soaps and detergents are produced by saponification reaction. Now, what are the characteristics of these soaps? Now, you do know soaps generally, if I just think from common sense, soaps, when I mix it with water, I get lather. right? They have property of lathering. They give this kind of foam, right? Soaps, I have generally seen that soaps are solid material, right? Solid material, they are hard material. They have cleaning property. Now, once it gives lather, they clean stuff. What do they clean? They clean dirt, they clean other oil. Say, for example, if you have oil on in your hand, you take detergent or you take hand wash and you wash your hands, and you will feel that your hand is dry now. There is no soap, there is no oily feeling. Apart from that, these soaps have fragrance. Why? Because they are made from esters. After esterification reaction, esters are produced. Esters are fragrant. Now, this is the raw material for that. These are the basic characteristics. Now, the most important characteristic of a soap or a detergent is cleansing action. Now, why does this cleansing action happen? Because soaps when soaps or detergents, when put into water, they lead to formation of micelle. They lead to formation of micelle. Now, what is this micelle? Now, micelle is a reason because of which we get that cleaning action. When soap is added to water, it leads to formation of different micelles. Now, micelles are basically compounds which lead to formation or a structure something like this, where every micelle, it will have two ends. One end is hydrophilic, that means it likes water. Hydrophilic, it likes water. And the other end is hydrophobic, it does not like water. So what happens, soaps or detergents, when they are added to water or in water, they lead to formation of micelle structures. Micelles, now these micelles, they form, or they align in such a way that the hydrophobic ends, meaning one that is not water. And what is not water in your cleaning action? Oil is not water. What is not water? Dirt is basically not water. So the hydrophobic part of this micelle, it will hold on to the dirt, it will hold on to the grease, it will hold on to the other impurities. And once we clean it along with this micelle, you will see the grease, dirt being taken away with this micelle itself. Because of this micelle formation, because of micelle action, we see, or we get, or whatever you pronounce, micelle or micelle, right? Because of this micelle action, we have cleaning of clothes, we have cleaning of utensils, we have cleaning of your hands, because this micelle will take away dirt along with it, because of this hydrophobic end. Please remember, it will have hydrophilic end and hydrophobic end. So hydrophobic end, soap molecule, it will have two ends, hydrophilic end, hydrophobic end. And the hydrophilic, it loves water, or it likes water, it will be with water. But the other part, it attracts the dirt, and when we wash it, everything goes out with that. All right, that's the basic idea. Clear? So we have seen carbon based compounds, we have seen hydrocarbons, we have seen saturated hydrocarbons, unsaturated hydrocarbons, their different chemical properties. We also discussed about some common compounds that we use: ethanol, ethanoic acid, that is acetic acid, and soaps and detergents. That's the basic completion of our NCERT chapter 4. As I told you, very important one. And this basically forms our chemistry background or chemistry knowledge required for civil service examination. All right, now let's take up some questions that can be formed on this. Questions which have come, I've seen in UPSC old pattern, some questions have appeared from chemistry from these parts, but many times questions have appeared in state PSC. All right, so here is one question: most carbon compounds are good conductors of electricity. You have to consider these statements. First one is, most carbon compounds are good conductors of electricity. Second statement reads, most carbon compounds form covalent bonds which are stronger than ionic bonds. All right, and you have to tell me which are correct, incorrect. Do let me know the answer for this in the comment section. I'll give the answer for these questions on my Telegram channel. The Telegram channel ID is this again, Rahul SAI 222. I'll also post these questions on my Instagram as a story also. Okay, so you can follow there and you can get the answers. Again, I would put this question as relatively easy. I have already given you a hint that you have to find incorrect ones. The second question is a soap molecule has hydrophobic head, hydrophobic tail, hydrophobic head, hydrophilic tail. Again, from these options you can check the answer. Again, this is a very simple question, The next question, I would put this question in moderate category. All right. Consider the following statements. Saturated hydrocarbons are the ones where valency of carbon is satisfied by single bonds only. Saturated hydrocarbons are the ones where valency of carbon is satisfied by double bonds only. And you have to tell which of the statements are correct. I hope through this interaction you have already gotten the answer. All right, you have already gotten the answers of these questions. These are fairly easy questions. Do attempt them in the comment section and you'll get the answers here. All right. So if you have liked this video, you can always follow me here at the rate Rahul Sai 222. Thank you for watching this video. Jai Hind.